Adjunct Professor Moran, Microeconomics 112. In this session, we're going to use our average cost data to find where marginal revenue and marginal cost are equal, determine whether we're going to apply the rule, profit max, loss min, or shutdown to determine the price quantity output that will be the best result for the firm. We're going to do that using both the numeric table and we're going to graph it, which we learned about in our last session. We graphed it using actual data, and then we learned how to freehand these graphs. So this graph looks complicated. It's a check mark, a flat saucer, and a slightly tippier saucer. Bigger gap here, smaller gap here, reflecting average fixed cost between. We don't include average fixed costs in the graph because fixed costs are not variable in the short run, so we exclude them. It won't help us make our decision, which is based on a comparison of price to average variable and average total, not average fixed. So the average fixed is implied in these graphs by the distance between average total and average variable, but won't be explicitly put on it, so it's not going to help us make a decision. These points should be minimums also. When you draw this curve, it has to go down to here and then start rising from there. And they get narrower. Okay. So, in our table, originally we had a price of 131. We go down the marginal revenue column. Notice that marginal revenue is constant. It's not a negative relation between price and quantity. We're assuming that price equals demand equals marginal revenue and also equals average revenue for a purely competitor, because the pure competitor is assumed to be so small he can sell an infinite amount at the current market price. He takes the price from the market, which the market does have a negative relation between price and quantity, as we'll see in the near future in another later video. We're going to set price equals marginal revenue equals average revenue equals demand, which occurs only because this is a perfectly less demand curve, and we've demonstrated in the prior video. We're going to set all of that equal to marginal cost, and that's going to give us the best outcome for the firm. The firm can't control this. They have to take the price and cost given to them, set by other markets. The only thing they have to decide is once they find marginal revenue equals marginal cost, they can determine whether they should remain open and make a profit, open even if they're making a loss, or shutting down. The idea here is if price is greater than average total cost, nothing says profit like price greater than average total cost. You're making a profit on every unit you sold times the number of units. But if your price is below your average total cost, you're losing money. But if your price is greater than average variable cost, then you can make a profit on your variable costs, which will help you pay down your fixed costs. So your total loss will be less than if you shut down, where you will incur your fixed cost in total. But if your price is less than your average variable cost, then there's no point in letting a worker in, because if you pay him 10 and you're selling it for 9, you're only adding an extra $1 to your fixed cost, for example. So your loss will actually be larger than if you shut down. So to determine if our price is 131, we just keep going down until we find marginal cost equal to 131. If they're never exactly equal, find the last time that marginal revenue is greater than marginal cost, and that happens at 9 units of output, price of 131. So we just determined price quantity for the individual firm. Now, what's going to happen at that price? Well, at 131, our price is greater than our average total cost of 98. So we will be profit maximizing. This firm will be making $33 a unit, marginal revenue 131 minus average total cost of 98 on 9 units. And if you multiply those, you'll get approximately $11.79. It may not square exactly because of rounding, but if you take the 9 units and the profit per unit of 131 minus 98, you'll get approximately $1,179. $11.79, and then if you let me try again. If you take 131 price times quantity, you'll get total revenue of $11.79. If you take average total cost of if you take average total cost of 98 multiplied by 9, you get total cost of 880. And subtracting the 1179 from the 880 will give you a profit of 299. The other way of calculating profit would be take 131 minus 98, giving you a profit per unit of 33, and multiplying it by 9, and that should give you 299 total profit. Let's graph this now. So graphing it will give us a curve that looks like this. So we have our average total cost curve, our average variable cost curve, which is barely visible in this. And our price line of 131. So we find where price equals marginal cost. There it is. This is the first part of our decision rule. So the decision rule is a two-step process. Price equals demand equals marginal revenue equals average revenue. That's the price line. Perfectly elastic, setting all those variables equal. Find where that equals marginal cost. So here we have it at 131. Find what the quantity is. The quantity will be 9. Once you've found this point, determine which prevails. Is price greater than average total cost, or is it less than average total cost? Is it less than average variable cost? And that will determine whether the firm should profit maximize, loss minimize, or shut down. Well, using the graph now, we can see that at 131, where marginal revenue equals marginal cost, marginal revenue is also our price because it's perfectly elastic. Marginal cost rising because of, at first, increasing marginal returns to scale, diminishing, and then negative marginal returns to scale. So here's our point. Here's our average total cost. Average total cost at 9 units was 98. Okay. So this graph is off a little bit, so just work with me that this is 98. So this firm is making a profit of $33 per unit. Alright, do you see the $33 per unit? 131 minus 98. And they're making that profit on 9 units. So that gives us length times width. This is a rectangle. That's the formula for a rectangle. So economic profit is this rectangle, 33 per unit on 9 units. And that comes out to 297. So for rounding, it's off a little bit, but the area of this rectangle is 299. Although the math works out to 297. All right, so that's your economic profit. The price is greater than average total cost, where marginal cost equals marginal revenue. Since price is greater than average total cost, this firm is profit maximizing. And what we did was, we determined how much profit we're making a unit on how many units and calculated the entire economic profit. This is a signal for firms to join this industry, which in the long run they can, but in the short run they cannot. Now, let's assume the price falls. All of our cost data is the same. If the price falls from 131 to 81, let's see what condition prevails. Profit maximization, loss minimization, or shutting down. Here's our marginal cost data, and here's our marginal revenue data. Marginal revenue equals price equals average revenue equals demand. So go down until you find where the two numbers are equal. Okay, here you are. This happens at 6 units. So, at 6 units, quantity will be 6, our price is 81, our average total cost, that's the beauty of this method, costs are now on a per unit basis and can be directly comparable to price, which is also on a per unit basis. Our average total cost here is 92. So we have a loss of $11 per unit. Now, what's true? We know that our price is less than average total cost. So we're going to either shut down, or we may loss min, or we may shut down, depending on now that we know price is less than average total cost, where is price with respect to average variable? Well, at 6 units of output, our average variable cost will be 75. So average total cost of 92, average variable cost of 75, our price is in between. This firm will stay open and loss minimize, and this is why. If the firm shuts down, the firm will incur its total fixed cost as a loss, which is 100. But if the firm stays open, even though it's losing money, it's going to lose $11 a unit on 6 units. So its loss will be $66 because of rounding it's 64 here. So it's better to lose only $66 than lose $100. And the reason it's not losing more than $100 is it's making a profit on its variable inputs. For example, it sells the unit, it sells something for $81, but perhaps the worker is only $75. So you're making $6 in every variable input, your variable cost. And that profit on your variable cost can be used to reduce the loss you incur on your fixed cost, which you'd have to pay in full if you shut down. That explains why, even though a firm is losing money, it may stay open in the short run because it's making its price is greater than its average variable cost. No firm can afford to lose money in the long run. This is a short run analysis. You can tell because you're making a distinction between variable costs and total cost. In the long run, you'll only have total cost because everything is variable in the long run, including your fixed cost. So let's look at this firm's economic loss. So we find marginal revenue equals marginal cost. Here it is at 81. Marginal cost, price, which also equals marginal revenue, equals demand, equals average revenue. And now we see that at this intersection of price equals marginal cost, we are losing money. The average total cost at 6 is 92. There is our $11 loss per unit on 6 units. So again, we're going to take the width times length and get an economic loss of approximately $66. $64 in the table because of rounding. So you would crosshatch this area indicating the loss, the economic loss, the shaded area. Average total cost will be something like this on this graph. So we're making a profit on our variable. Our price is higher than our average variable cost. So we're making a gain on the variable of this much per unit on this many units, which will help us offset our fixed costs. But overall, the firm is losing money. Finally, we'll do a shutdown situation. So let's say the price falls to 50. At $50, the price is less than your average variable cost. So at $50, go down until you hit marginal cost of 50, right? It doesn't exist. So the price for $50, you wouldn't bother opening because you're losing money on your variable cost as well. So there's no point in opening. So the average total cost curve never gets lower than 50, so price is less than average variable cost as well, and that gives us a shutdown situation. So we've demonstrated each one of the scenarios. Profit maximization, where price is greater than average total cost. Loss minimization, where price is less than average total cost but greater than average variable cost. And shutdown, where price is less than average variable cost. First, we find this criteria where the price or marginal revenue line intersects marginal cost, and then determine which of these conditions are met. You should be able to freehand these. It's the same graph each time. The only thing you're doing is putting the price in a different position. So, profit max, price is greater than average total cost. Go over from that intersection of down from price, marginal cost, to the average total cost curve, shade this area, that will be your economic profit. Next, very same curves, a check mark, a relatively flat saucer minimizing where it crosses marginal cost. This is average variable cost. A tipier saucer meeting there and going up, that's average total cost. Getting closer, indicating fixed cost is declining with increases in output. And now your price is between, this will be loss min, your price is between average total and average variable at this quantity. So here is your economic loss. You go up from this point, come over, and this is average total cost loss min. You're losing this much money per unit on this many units. This shaded rectangle stopping here is your economic loss. Finally, our last scenario, freehanding, check mark, flat saucer minimizing where it crosses marginal cost is your average variable cost curve. Tipier saucer minimizing here, average total cost. If price is below average variable cost completely, then you have a shutdown situation. We'll practice with this a little more in the next video, and then we're going to analyze the industry supply and demand curve.